Chapter 6, Technical Energy System Analysis. All right, everyone. Today we're going to explore the heart of EnergyPLAN's simulation process, what we call the Technical Energy System Analysis. Think of it like running a big test kitchen where you try different recipes to see what happens with your ingredients. The goal is to see how your entire energy system behaves when you mix electricity, heating, transport, storage, and flexibility together, hour by hour, throughout the whole year. This chapter focuses on the step where we look at how well the system runs technically, before thinking about costs or market prices. We start with a key concept called balancing demand and supply. Imagine you're cooking a meal. You have to balance what people want to eat with what you can cook. EnergyPLAN looks at every hour's energy demand. This includes electricity for homes, heating for buildings, fuel for transport, and other energy uses like cooling or desalination. At the same time, it adds up all the energy you produce from wind, solar, hydro, power plants, CHP units, and even electric cars that can feed electricity back to the grid. Then EnergyPLAN asks, do I need extra power from condensing power plants, or can I get away without using them? Condensing power plants are like emergency backup cooks. They jump in when you can't meet demand, but aren't very efficient. The system only uses them when necessary and always checks if grid stability requires them to be running. EnergyPLAN also keeps track of when you produce too much electricity. This is called critical excess electricity production, or CEP, which is like cooking too much food that nobody eats. It can also track exportable excess electricity production, where you can send the extra power to neighbors. Think of giving your extra cake to your friends next door. Next, we move to district heating systems, focusing on two main strategies. Strategy 1 focuses on making enough heat to keep everyone warm, prioritizing solar heat, industrial heat, CHP units, and then heat pumps before finally switching on the boilers. It's like using your solar cooker first, then the efficient stove, and only using your old noisy boiler if needed. Strategy 2, on the other hand, tries to reduce electricity exports by adjusting the way heat is produced, like being extra smart with your kitchen appliances to avoid food waste. Then comes the fun part, flexibility. EnergyPLAN allows you to shift certain demands around, like charging electric cars when there's excess power, or using heating and cooling more flexibly. Imagine choosing to iron your clothes at night when electricity is cheaper and greener, instead of during busy daytime hours. You can also model flexible demands for days, weeks, or even months to make your system smoother. Hydropower comes next. Think of hydro storage like a big water battery. You can store energy when there's excess power and release it when you're running short, while always making sure the water reservoir doesn't run empty or overflow. EnergyPLAN adjusts how hydro works to reduce backup power needs and excess electricity. Then we have individual systems like home CHP and heat pumps. The model prioritizes solar thermal heat, uses storage smartly, and switches on CHP or boilers only when really necessary. This helps reduce overproduction and keeps energy use efficient at the household level too. We also simulate electrolyzers that produce hydrogen. Instead of wasting excess electricity, we can make hydrogen to use later. EnergyPLAN even balances hydrogen storage to make sure there's enough fuel for transport and other uses without wasting energy or money. Heat storage is another crucial element. By storing extra heat when there's too much electricity and releasing it when there's a shortage, the system avoids the need to switch on inefficient power plants. It's like keeping leftovers in the fridge for later meals instead of cooking something from scratch. EnergyPLAN doesn't forget about transportation. It models smart charging for electric vehicles and V2G, or vehicle to grid, where cars can give power back to the grid when parked.
This turns cars into mobile batteries, helping stabilize the system and reducing reliance on traditional power plants. Electricity storage, including batteries or pumped hydro, is simulated to absorb excess electricity and release it when needed. It prioritizes using storage before wasting electricity, which helps smooth out fluctuations from renewables like wind and solar. Finally, EnergyPLAN models desalination systems, where extra electricity can be used to produce fresh water from seawater. This way, no electricity goes to waste, and we meet fresh water demand efficiently. Overall, technical analysis in EnergyPLAN acts like a detailed chef's practice round, checking hour by hour if your energy system runs smoothly, how much excess you have, where backup is needed, and how flexible actions like smart charging or heat storage can improve things. It's a perfect way to find out if your future energy system recipe is balanced, efficient, and smart before worrying about the money side of things.